Hello and welcome all students. How you are keeping yourself? In today's session, we will discuss about bond parameters in the covalent bond. So what kind of parameters bond does have? Have you ever heard the term bond energy, bond length, bond angle, and also bond order? What are they? What does they mean? And how to calculate them? And why to calculate them? So all these questions I will teach you in this today's class, where we will discuss different bond parameters. So let's start the topic bond parameters. So students, now we shall discuss in this class about the covalent bond, type of the covalent bond, Lewis representation of simple molecule, formal charge, and limitations of octet rule. We shall also discuss about the bond parameters of covalent bond in this unit, and in the end of this today's class I will tell you about the appearance of covalent character of ionic bond, which are furthermore explained by the Fazan's rule. So basically Fazan's rules are there to explain how in the ionic bond covalent characters are appeared. Alright, so let's start the today's class. In the today's section, first we shall study about the covalent bond. Now you must be already knowing that covalent bond is the mutual sharing of electron pair between the combining atoms. So the chemical bond which is formed due to the mutual sharing of pair, what do you mean by mutual? Means both of them give one electron. Alright. So this is mutual sharing of pair of electron between the two combining atoms, which is called as covalent bond. In this type of bonding, electrons are not transferred. Remember, it is not transferred, just shared. Transferring of electron take place in the ionic bond. So here each chlorine atom share one electron with the another chlorine atom. Now you see in this picture, this electron belongs to one chlorine and this electron belongs to another chlorine. Now when they form the covalent bond, this electron pair is shared by both of them, and which forms the covalent bond. So covalent bond is simply sharing of electron between the atoms. Alright. Now how many type of covalent bonds are there? As you know, covalent bond is the sharing of electron. There are three type of covalent bond. One is the single bond, another is the double bond, and the last one is the triple bond. Single bond species are those which have one bond between them and one shared pair. In the double bond there is a two shared pair, and of course in the triple bond there are three shared pair between the two atoms. Now what is the example? What are the examples of the single covalent bond? This bond is formed by the sharing of one pair. Like I said, it is sharing of one pair of electron between the two atoms. This example, example of this single covalent bond, it could be chlorine, or it could be hydrogen, or it could be water. In the water also, in the HCl also, you see, in this HCl, what you see here is the pair of electron, which is further shared between hydrogen and chlorine. Same like water. In the water, pair of electron is shared between oxygen and hydrogen. So here chlorine atom share its one electron with the hydrogen atom in HCl and form one covalent bond, and thus there is a formation of HCl. In the Cl2 also there is a sharing of one electron between two chlorine atoms. The same happens with the hydrogen. Here you see is the shared pair of electron in between two atoms of hydrogen. Now double covalent bond. Do you know what is the structure of carbon dioxide? This is the structure of carbon dioxide. Now what do you see? In between carbon and oxygen there is a presence of double bond, which simply means two electrons of carbon are shared with the two electrons of oxygen. So this is double covalent bond. This you might see in CO2, or you might also see this in C2H4. What is the structure of C2H4? This one. Again you see there is a double covalent bond between carbon and carbon, C2H4. Alright, also CO2. Now there are quite a few examples of triple covalent bond. like we discussed in this, bond is formed by the sharing of 3, not 1, not 2, 3 pairs of electron between two atoms. Like nitrogen. What happens in nitrogen? See, this is what exactly happens in nitrogen. There are 3 pair of electron which are shared with each other. Of course, out of these 3 bonds, one is the sigma bond and rest 2 are pi bond, which we already discussed in the previous classes. And also in C2H2. C2H2 is ethine molecule, which look exactly like this, in which there is a triple bond between carbon and carbon, out of which 1 sigma plus 2 pi bond, 1 sigma and 2 pi bond are there, right? Now, another topic of discussion of today's session is Lewis representation of simple molecule. So, how to represent, how to draw the Lewis representation of any species? If you have any simple molecule, then how you would draw the Lewis representation? So, there are few steps you have to follow. Step number 1, add the valence electron, you know valence electron, outer electron of each atom in the molecule. Now, no matters how many kind of atoms are there in the molecule, you have to draw the valence electron for each atom in the molecule and know the total number of electron required to write the Lewis dot structures, right? For example, in CO2, carbon has 4 valence electron in the outer shell and oxygen has 6 valence electron in the outer shell. Alright, so the total electrons required are 4 for the carbon and 2 for each oxygen, that is 16. So in total 16 electrons are required. Now furthermore, in the step 2, if you have a species carrying negative charge, which means anions, so for any anion with respect of each negative charge, you have to add 1 electron. Like say for example, in this you have iron carbonate CO3 minus 2, in which you can see this there is a presence of minus 2 charge. So the total electrons will be 4 for the carbon, 6 for oxygen, and there are 3 oxygens, you see, 22 plus, along with this 22, now we will add 2 electrons because of this negative charge. So in total it becomes 24, and here 2 is added for 2 negative charge. Because of the 2 negative charge, we added 2. In the step 3, for cation, each positive charge would result in the subtraction of electron. You see, this is just reverse of the step number 2. If the species is not carrying a negative charge, what if it is carrying a positive charge, like NH4 plus? If it is carrying a positive charge, then you have to remove, you have to subtract the same number of electron which is equal to the positive charge. So for cation, each positive charge would result in subtraction of 1 electron from the total number of valence electron. So whatever the number of valence electron, 1 electron will be removed for each positive charge. Say for example, for NH4 plus, total electrons will be 5 for nitrogen, 4 for hydrogen, 1 for each hydrogen, total 9, and then we shall remove 1 electron because of this positive charge which is over there at NH4 plus. So it will be 8. For your reference, here 1 is subtracted for 1 positive charge. Just go through it once. Now coming furthermore, in the step 4, by knowing the skeletal structure of the compound, it is easy to distribute electron as bonds between the atom. By it says, when you know the skeletal structure, then you have an idea, then you get to know how to distribute the electron between the atoms according to their bond. And in the next step, after using electron for the single bond, the remaining electrons are adjusted either for the multiple bond or lone pair of electron. Multiple bond, say for multiple bond means either you say double bond or you say triple bond, and if it is not there, it will be adjusted for lone pair. What is lone pair? You must be knowing. It is a pair of electron do not involved in any kind of bond. So the pair of electron which is not involved in any kind of bond is called as lone pair of electron. Alright, then we shall discuss about the formal charge. After drawing the Lewis dot structures, we shall also discuss the formal charge. Let me tell you one thing, formal charge, it is part of your syllabus, but it is not very important these days. So we shall discuss the formal charge in brief manner. So what it is defined as the difference between the number of valence electron of that atom in an isolated or free state, either in the isolated or in the free state, and the number of electrons assigned to that atom in the Lewis structure. So summary of the story, you cannot calculate formal charge without drawing the Lewis structure. That is the reason why we first studied how to find out the Lewis structures. So here is the formula for the calculation of formal charge. How to calculate the formal charge? Fc, total number of valence electron in the free atom or the isolated state, like we mentioned here, free or isolated. You know what is free? Hydrogen is free, but H2SO4 is not free. Hydrogen is free form, but H2SO4 is not free form, it is molecule. So the total number of valence electron in the free atom minus total number of non-bonding. What are the non-bonding electron? Lone pair. Lone pair of electron are non-bonding, minus half of the total number of bonding electron. So whatever the number of bonding electron, total number of the bonding electron, total number of valence electron minus half of the non-bonding minus half of the bonding. So here comes the formula in short. Formal charge is equals to valence electron minus number of electron in non-bonding minus half of bonding electron. This is how we calculate the formal charge. Now what is the importance of the formal charge? Why do we calculate formal charge? What is the importance? See, there are many possible Lewis structure for a particular molecule. For a given molecule, any given molecule, you can form variety of Lewis structures. So the structure with the lowest energy is the actual representation of the molecule. In the Lewis dot structure, the structure with the lowest energy is the actual representation of the molecule. Formal charge help in the selection of the lowest energy structure. So with the help of formal charge, you get to know, you predict, you find out which structure out of these has the lowest energy. And how to do this? You see, point number 4, lowest energy structure is the one with the smallest formal charge. Now you got it, students? Now it is very easy. So the structure for which formal charge is lowest, minimum formal charge, the smallest value of formal charge. If the value of formal charge is smallest, then energy will be lowest. And if energy will be lowest, stability is maximum, and that would be the actual representation of the molecule. Alright. Now we shall see the discuss of the limitations of the octet rule. What are the limitations of octet rule in formation of covalent bond? We already studied the octet rule. According to this Lewis dot structure, it should have 8 electrons in the outer shell. Those species which have 8 electrons in the outer shell, they are said to follow the octet rule. So here are few exceptions which are important to mention for the octet rule. Number one is the incomplete octet of the central atom. Incomplete octet means less than 8 electron. See, in some compounds, the number of electrons surrounding the central metal atom is less than 8. They have less than 8 electron. For example, members of the boron family, members of the beryllium. You see, beryllium, how many electrons beryllium is having in outer shell? Beryllium is having just 2 electron in outer shell. So even if beryllium pair both of its electron with the another species, say Z, then also beryllium will have 4 electrons in the outer shell. Then also beryllium will have maximum 4 electrons in the outer shell, which is quite a low figure than octet. So I say that octet rule is not followed here. Here we can say that octet rule is not followed. So the central atom, beryllium and boron in the molecule like BeCl2, like BeF2, like BCl3, like BF3 do not possess octet. Their octet is not complete. In BeF2, BeCl2 there are 4 electrons in the outer shell, while in the BCl3, BF3 there are 6 electrons in the outer shell. So definitely octet is not completed. Like I said, beryllium atom has 4 electrons in its valence shell, 2 of its own shown by the red dot and the other 2 shown by the blue dot from the 2 covalently bonded chlorine atom in BeCl2 and in BeF2. While boron atom, it has the 6 electron in the valence shell, 3 of its own which belongs to boron itself and the other 3 from the 3 covalently bonded fluorine or chlorine atom. So even though they form covalent bond, their octet is still not complete. They are exception of incomplete octet. Another example is odd electron molecule. Odd is what? And yes, you are right. You are guessing it right. It is reverse of even. We have two kind of figures, even and odd. So when any species possess odd number of electrons in the outer shell, these are called as odd electron molecule. Example is nitric oxide, NO, and nitrogen dioxide, NO2. In the nitric oxide NO and nitrogen dioxide NO2, octet rule is not at all satisfied for all the atoms. You see, NO or the NO2 where odd electron is present, they are not having electron in the even manner, they have electrons in the odd number. So they are also exception of the octet rule and they are called as odd electron species or odd electron molecules. The another one, you see, another exception of the octet rule is the expansion of octet. So what do you mean by expansion, students? Yes, again you are guessing it right. Very good. Expansion means more. So according to the octet rule, there should be 8 electrons in the outer shell, but if electrons are more than 8 in number, then it is called as expansion of octet and it is called as expanded octet. Means more than 8 electrons in outer shell, right? So element in and beyond the third period of the periodic table, they have 3d orbitals, not up to the second period, because 3d appears from third period. According to the n plus L rule, 3d orbital do not fill in the third shell. It started filling in the fourth shell. So for the members of third period, this 3D subshell remain empty and it is available for the bond formation or for the expansion of octet. Now by using orbitals of this 3D, when these orbitals of 3D, they involve themselves in the bonding, apart from the 3s and 3p. 3s and 3p, they are by default engaged in the bond formation, but apart from the 3s and 3p, if 3d is also engaged, then such molecule can form more than expected bonds in their outer shell, and such elements, there are more than 8 valence electron around the central atom, and this is termed as expanded octet. More than 8 electrons in the outer shell. Here are some examples of the expanded octet. Like in PCl5, you see in the PCl5 there are 5 chlorine atoms around the phosphorus. Now you count 2 bonds for each chlorine, 2 electrons in each bond. How many bonds are there? 5. 2 electrons from each bond, total 10 electrons around the phosphorus atom. Same goes with the sulfur. It is one more step ahead. It is having 12 electrons, you see students. It is having 12 electrons in the outer atom. So here also this is the example of expansion of octet. What are the drawbacks of the octet rule? Octet rule never account for, it does not account for shape of the molecule. Shape of the molecule explained by, I taught you this in the previous lectures, it is explained by VSEPR, valence shell electron pair repulsion theory. Relative stability of the molecule, Lewis structures or octet rule never explain about the relative stability of the molecule. It has not given any idea of the energy of the molecule or compounds of the noble gases, not explained by the octet rule. Why and how noble gases they form compound? Because they already have complete octet. So this is not explained by octet rule. What do you see in this picture are called as parameters of a covalent bond. Covalent bond, which is formed by the sharing of electron, have different parameters like bond length, bond angle, bond order, bond energy, polarity in bond, and the resonance. Now we shall discuss these bond parameters. First is bond length. What do you understand by bond length? It is average distance between the centers of nuclei of 2 bonded atoms, like this one, yellow and blue. These are 2 different atoms which form bond. So the distance between center of their nucleus, my dear students, this is bond length. Alright, and this is defined in equilibrium. When equilibrium is established, bond is stable and distance between them do not changes. This bond length, it can be measured as a covalent radius or the van der Waals radius, or sometimes metallic radius or ionic radius, right? So which factors determine the bond length? Size. Bond length increases with the increase in size. For the larger atom, if the atoms are smaller, bond length will be less, and if the atoms are larger, definitely bond length will be more. So bond length increases with the increase in size of atom. Then again is multiplicity, means bond order. As the number of bond increases between the atoms, here only one bond is there between carbon and carbon, here it is 2 and here it is 3. As the number of bond increases between the 2 atoms, as a consequence, bond length decreases. Because when the number of bond increases, strength of the bond increases. When strength of bond increases, bond length decreases. Another bond parameter is the bond angle, and it is very simple. What is angle? Angle is always plotted between two. So the angle between orbitals containing both bonded and non-bonded electron pairs around the central atom of a molecule is called as bond angle. See, this one is the oxygen atom, and it is surrounded by two hydrogen atoms. So here is the bond angle. In case of water, it is 104 degree and 5 minutes. This is the bond angle in water molecule. Angle of volume, bond angle may be different in the different species, but it is expressed in degrees, minutes and seconds. So it is 109 degree, 28 minutes, 104 and 0.5 degree. This is absolute degree. This structure is tetrahedral in CH4. This is band shape. So bond angle is different for different species. Another bond parameter is the student bond energy. What is bond energy? It is the absolute amount of energy which is required to break 1 mole bond. If you need to break 1 mole bond, whatever the energy required is the bond energy, right? And if you are forming a bond, then the same amount of energy will be released. So if you are breaking a bond, it is moreover it should be called as bond dissociation energy. This is the bond dissociation energy of hydrogen, and this is the value of bond dissociation energy for oxygen. And larger the bond dissociation energy means it is difficult to break this bond, so stronger will be the bond. Larger the bond dissociation energy, stronger will be the bond. Another property is bond order. Bond order is what? It is simply number of bond between the two atoms in the molecule. In H2 there is a single bond between H and H, so bond order is 1. When double bond is there, bond order is 2, and when triple bond is there, like in N2, bond order is now 3. Now we shall discuss about the polarity in covalent bond. You know what? Covalent bond never remains 100% covalent. So the covalent bond could be polar or the non-polar. Non-polar means there is no polarity. Polar means there is a polarity. There will be a positive pole or the negative pole. It solely depends upon the electron negativity. Because of the electron negativity, electron pair, because of the difference in the electron negativity, electron pair of the bond shift towards the higher En atom, and this creates development of the polarity. So when the electrons are attracted towards more electron negative atom, it gives rise to the polarity, and partial positive and partial negative charges develops in an atom. Say for example in HCl, this electron pair partially shifted towards chlorine, so there is a development of partial negative and partial positive charges, because of which this bond becomes non-polar. Alright students, so this was all about the today's session. We discussed so many different topics here. Now the further remaining topics we shall discuss in the coming classes. Alright, I hope you liked and understood the today's topic. Please keep studying and keep coming.